the equation x cubed plus x minus 1 equals 0 has at least one real root, at least one. And this root can be located in this interval, okay? To show at most one, okay, we use the method. We prove this by a contradiction. Use the indirect proof. Suppose, on the contrary, or to the contrary, this equation has two, at most one solution. Okay. Suppose on the contrary that, this means that equation, this equation has two different zeros, real solution. One is A, another one is B. 我们要证明至多只有一个的时候，我们用间接证法，就是矛盾证法。Indirect proof, or we prove this by a contradiction. Okay, then this function is a polynomial function. It's continuous on this closed interval AB and is differentiable on the open interval AB, and f of A equals f of B. In fact, equals 0. So by Rawls' theorem, okay, but if we compute the derivative of this function, we will see 3x squared plus 1. Aha! This cannot be 0. For all real, or for x in this interval. So this is a contradiction. Okay. If this statement is true, then this cannot happen. For all x, for arbitrary x, if we put x here, it's not 0. But this statement says for some real number f prime equals 0. So these two statements, if this true and this true, will lead to a contradiction. So by the indirect proof, method of indirect proof, therefore, this equation x cubed plus x minus 1 equals 0 has at most one real solution. So here we use the intermediate value theorem. And here we use Rawls theorem. Okay, by 1 and 2, at least one real solution, and at most one real solution. The conclusion is, therefore, the equation okay. Got it?
Sure.
Mhm.
This one can why you just
This function, if you consider the zeros in the complex number, the set of all complex numbers, this equation has the 3 roots, but only one of them is real root. Because we want to show this equation has exactly one solution. So the corresponding function will be this one, this polynomial function. This is the reason why we consider this function. Because by inspection, if you can, usually we want to find some if you want to locate the root, usually we use numbers -1, 0, 1, or 2, -2. And we start from some small integers, easy to calculate. So, in fact, the first part already learned before. So the essential of this example is the second part. At most one real root. At least one real root already learned or already solved before. But for completeness, I give the whole solution of this example. So we consider this one. If use 0, obviously this is negative. If we consider 1 to 1 cancel, this is a 1. So this example already been designed. It is designed under some consideration of the author of this textbook. So sometimes you can find examples are not too hard, but sometimes not so easy. Okay, so this is a very good example. If you want to show some equation has exactly two real solutions, you can find the third value. Maybe here f of 2 is positive and negative, then the signs change and signs change. So by intermediate value theorem, they are at least 2 real solutions. And also, suppose on the contrary that f of a equals 0, f of b equals 0, f of c equals 0 for some a less than b and b less than c, means more than 2. again use the Rolle's theorem, you will find f prime c has at least two. Uh-huh. 1, 2, 3. Okay. I mean, if you want to show some equation has exactly two real solutions, again, and these two means you use intermediate value theorem. Consider another number, maybe f of 2 will be negative size change. So at least 2. At most 2. On the contrary, suppose f of a equals 0, f of b equals 0, f of c equals 0, then by the main value theorem, if these conditions are satisfied, then there must be C1 and C2. F prime at C1 is 0, F prime at C2 is 0. Again, sometimes you will find F prime X maybe at most or no real solution. Again, the contradiction. OK， 听得懂吧？就是我们通常要证明一个方程式恰有几个实根，恰有2个实根，那至少有2个用中间值定，这个我们都知道，高中就学过。比如说，我们可以考虑一个函数，在0小于0、1大于0，2的地方搞不好小于0，就有2次符号改变，所以它至少有2个根。要证明这个有2个根，那假设相反，与事实相反 ，on the contrary，or to the contrary， 与事实相反 ，f_a 等于0 ，f_c 等于 f_c，b 等于 f_c 等于0 ，a 小于 b 小于 c。如果有某3个实数不一样的实数，使得这个都等于0，代表它至少有3个实根。那 f 在 a 的地方是0，在 b 的地方是0，在 c 的地方也是0。根据均值定理呢 ，a、b 中间有一个地方一阶导数是0，b、c 之间有个一阶导数是0。往往呢，一阶导数算出来发现，根本不可能有2个地方会导数是0嘛，就得到矛盾，因此至多只有2个啊。这就是有关均值定理或洛尔定理的一个应用，帮助你证明至多，至少通常用中间值定理，2个和解恰有几个实根啊？实数解是实根的意思，讲函数是讲几个0点啊，有哪些东西带进它的0叫 zeros， 那这个解叫 solution 或者 root。OK，
You said if you change the signs, they're going to get the solution.
Yes, they change the signs. This function change the signs from 0 to 1, change the signs. So by the intermediate value theorem, means 0 is an intermediate value of this function. Okay. If a function, this is a value of the function f. And this is also a value of this function. Any number between these two values is called an intermediate value. This is the definition. Any number n is called an intermediate value. And this theorem says if f is continuous on the closed interval ab and n is an intermediate value, n is a value between f of a and fb, then there must be somewhere fn, and this number whose value is this intermediate value is n. Now, if we consider n to be the number 0, then 0, this means n is an intermediate value of f_a and f_b, or n between f of a and f of b. If f of a is smaller, then this statement is true. Then if f of a is larger one, greater than f of b, then n between f of a and f of b means this relation. Okay. If f is continuous on this closed interval and n is an intermediate value of these two values, then n must be a value of this function. And of this function at some number between a and b. This is what intermediate value theorem says. Okay. So sometimes you had better review, practice, and repeat what I have taught in the classroom. Well, very good. So this example gives us a very good lesson when we want to show some equation has exactly maybe 3 solutions. By intermediate value theorem, we can prove if you choose a good function and then choose the right numbers, you can show this function. Yes, this equation has at least 3 real solutions, and use Rawls' theorem. You can suppose f of a equals f of b